Permutation and combinations, part 2. So state if each scenario involves a permutation or a combination. So Mofor and Daryl are planning to trips to 10 countries this year. There are 14 countries they would like to visit. They are deciding which countries to skip. So they are planning trips to 10 countries this year out of and there's 14 trips that they like to visit. So essentially, they want to choose which countries they are going to skip. Now, they do not specify what particular countries to pick first. So since there's no specification, order doesn't matter, and this would just be a combination. Because they don't specify on the countries at all. Okay. Next one. Okay, a team of 13 basketball players need to choose a captain and a co-captain. So, since out of the 13 basketball players, there needs to be one person to be a captain and one person to be a co-captain. That means order does matter. So, as a result, you guys, this is a permutation. One person needs to be a captain and one person needs to be a co-captain. For this one, the batting order of 10 players on an 11-person team. So since you have to have a batting order and there's a specific person for each batting order, like two people can't be the same batting order. Once one person fills up a slot for one batting order, another person has to fill out another slot. So order does matter, which means this is a permutation. All right. A group of 35 people are going to run a race. The top 7 finishers advance to the finals. So the top 7 finishers advance, but it doesn't specify like first place, second place, third place, or whatnot. So that means order doesn't matter. So this is just a combination. Okay, number 5. All right, for the rest, it says state if each scenario involves a permutation or combination, then find the number of possibilities. So first, this says selecting which 7 players will be in the batting order on an 8-person team. So this one differs from this one, you guys, because in the first one, it specifically says what is the batting order for the 10 players. This one says selecting which 7 players that will be in the batting order. So how you choose those 7 players doesn't really matter. So this one is going to be a combination. And now we are going to see what combination in order to get the 7 players in the batting order. So it's going to be 8, which is the total, choose 7. And this is going to be 8 factorial over 8 minus 7 factorial and 7 factorial, which is 8 factorial over 1 factorial over 7 factorial. And this is going to be 8 so we're going to make that 8 times 7 factorial all over 1 factorial, you guys, is 1, and 7 factorial. These are going to cancel. So all we're left with is 8. 8 possibilities. Alright, 6. There are 15 applicants for 2 manager positions. Okay, so 2 manager positions, but it does not matter how we choose the manager positions. Like one applicant 15 could be the first manager and applicant 13 could be the second manager, but it does not matter which 2 that we select is a specific manager. They're both managers. So this is going to be combination. The order doesn't matter. So we're going to have 15, choose 2 of them. So 15 factorial out of 15 minus 2 factorial and 2 factorial. 15 factorial all over 13 factorial and 2 factorial. So 15 times 14 times 13 factorial all over 13 factorial times 2 times 1. These cancel. Now we got this. Well, the 1 pretty much is just a 1, you guys. 2 goes into 14 7 times. So we got 15 times 7, which is simply just equal to 53105. Okay. 7. You are setting the combination on a 5-digit lock. You want to use the number 62413, but don't care what order they're in. Okay, so this one says it doesn't matter what order that these numbers are specifically in, but when you put a number in a slot, that number stays there, and then the other numbers have to be, they can't go in that position. So let's say you guys have this, right? Okay, if I pick a 6 here, that means another 6 cannot go there. So you can either have these to pick from. So this one's weird in its wording, you guys, where it says, but don't care what order they are in, but there is still a specific order that you have to put these specific 5-digit locks. So since it's like that, this one's going to be a permutation, because order does matter for that problem. So you got 5, choose 5, which is equal to 5 factorial over 5 minus 5 factorial. 5 factorial over 0 factorial. 0 factorial, you guys, is 1. So we just have 5 factorial. 5 times 4 times 3 times 2 times 1, which is essentially equal to 120. Okay, 8. 3 out of 15 students will ride in a car instead of a van. Well, 3 out of 15 students will ride in a car, but the order you put the 3 in doesn't matter. So that means it's combination. So 15, choose 3. 15 factorial over 15 minus 3 factorial. 3 factorial is equal to 15 factorial all over 12 factorial, 3 factorial. So 15 times 14 times 13 times 12 factorial. I stopped at 12 because I already know there's a 12 on the bottom. And then 3 times 2 times 1. These are going to cancel. Now we'll cancel this stuff. So I could cancel up to 1. Okay, I know that I could divide the 3 into 15, and that would give us 5, and I could divide the 2 into the 14, and that would give us 7. So 5 times 7 times 13, you guys, and that's gonna give you guys 455. Alright. 9. Okay, a team of 12 dodgeball players need to choose a captain and a co-captain. So out of those 12 players, there needs to be a specific person that's a captain and another slot that's for co-captain. So this is permutation. So 12, choose 2 of them. Oop, that's a C. So 12 factorial over 12 minus 2 factorial, which is 12 factorial over 10 factorial. So 12, I'm going to go all the way to 10 factorial, stop there because I know I can cancel out the 10. So that just leaves us with 132 options. Okay, 10. There are 60 people in a meeting. They each give a Valentine's Day card to everyone else. How many cards were given? So every single person needs to give a Valentine's Day card to everyone else. So you're specifically looking for the 60 people, or since one of them is included, you're looking for 59 people if you're one of the 60, and you're specifically finding an order to give someone, right? So order does matter in here, so this would be a permutation. So then it's going to be 60 choose. How many people were given? 2. So 60 factorial over 60 minus 2 factorial, which is 60 factorial over 58 factorial. 60 times 59 times 58 all over 58 factorial. These cancel. So all you're going to give is 60 times 59, which is 3,540. Okay. 11. So 30 students at a meeting, they each give a Valentine card to everyone else. How many cards were given? Alright, so this is the exact same one as the one previously, so permutation. Because, right, you have to give a card to every single person. Every single person needs a Valentine's Day card. So you got 30, choose 2, 30 factorial out of 30 minus 2 factorial. 2, you guys, because 2 is you giving out to each person, like one-on-one. So once you give it, that's considered 2 people. Factorial over 28 factorial, these cancel. So we have 870. Okay, Carlos has a homework assignment in 6 subjects. He only has time to do 4 of them. 4 of them, but any 4, right? Because they don't specify, so this is combination. So 6, choose 4 of them. So 6 factorial over 6 minus 4, 4 factorial, which is 6 factorial over 2 factorial times 4 factorial. So for the 6, I'm going to stop all the way to 4 factorial. This 2 factorial is going to be 2 times 1 times 4 factorial. Cancel. So if you cancel here, the 2 goes into the 6 3 times, so 3 times 5, which is 15. Okay, 13. A group of 20 people are going to run a race. The top 3 runners. So since there's going to be top 3 runners, that means there's a specific order. So that means this is going to be permutation. We're going to have 20, choose 3 of them. 20 factorial over 20 minus 3 factorial. 20 factorial over 17 factorial. So for the 20 factorial, going to go all the way to 17 factorial so that we can cancel those off. So all we have is 20 times 19 times 18, which to be 6,840. Alright, there are 190 politicians at the meeting. They shake hands with everyone. How many times will they shake their hands? Okay, this one's a bit different from this one, you guys, because the act of shaking hands, that works for both. Like, for example, like if you shake hands with someone, both of you have completed the task of shaking hands, right? It counts for both people. But for the Valentine's Day one, when you give a card to someone, that only counts for the person who gives it, not receives it, right? So for the Valentine's Day card, order does matter because you have to go you have to go find people, and then that other person has to go find people, which means order does matter. But the fact of shaking hands with everyone, since since shaking hands is a fulfillment for both people, this one the order doesn't matter. So it doesn't matter whose hands you shake because it accomplishes for both people. So this is going to be a combination, and it's going to be 190 choose 2. So 190 factorial over 190 minus 2 factorial 2. 190 factorial over 188 factorial 2 factorial. So 190, I'm going to stop all the way to 188 factorial. So these cancel. The 1 cancels, the 2 cancels with the 190, so that's going to be 95. So you guys are going to get 95 times 189, which is equal to 17,955. So hopefully you guys, this helps. See you around.